Without a doubt, the most exciting scientific observation of 2012 was the discovery of a new particle at the CERN laboratory that could be the Higgs boson, a particle named after physicist Peter Higgs. The Higgs field is thought to give mass to fundamental subatomic particles like the quarks and leptons that make up ordinary matter. The Higgs bosons are wiggles in the field, like the bump you see when you twitch a rope. But how does this field give mass to particles? If this sounds confusing to you, you're not alone. In 1993, the British science minister challenged physicists to invent a simple way to understand all this Higgs stuff. The prize was a bottle of quality champagne. The winning explanation went something like this. Suppose there is a large cocktail party at the CERN laboratory filled with particle physics researchers. This crowd of physicists represents the Higgs field. If a tax collector entered the party, nobody would want to talk to them, and they could very easily cross the room to get to the bar. The tax collector wouldn't interact with the crowd in much the same way that some particles don't interact with the Higgs field. The particles that don't interact, like photons for example, are called massless. Now suppose that Peter Higgs entered the same room, perhaps in search of a pint. In this case, the physicists will immediately crowd around Higgs to discuss with him their efforts to measure the properties of his namesake boson. Because he interacts strongly with the crowd, Higgs will move slowly across the room. Continuing our analogy, Higgs has become a massive particle through his interactions with the field. So, if that's the Higgs field, how does the Higgs boson fit into all of this? Let's pretend our crowd of partygoers is uniformly spread across the room. Now suppose someone pops their head in the door to report a rumor of a discovery at some distant rival laboratory. People near the door will hear the rumor, but people far away won't, so they'll move closer to the door to ask. This will create a clump in the crowd. As people have heard the rumor, they will return to their original positions to discuss its implications, but people further away will then ask what's going on. The result will be a clump in the crowd that moves across the room. This clump is analogous to the Higgs boson. It is important to remember that it is not that massive particles interact more with the Higgs field. In our analogy of the party, all particles are equal until they enter the room. Both Peter Higgs and the tax collector have zero mass. It is the interaction with the crowd that causes them to gain mass. I'll say that again. Mass comes from interactions with the field. So let's recap. A particle gets more or less mass depending on how it interacts with the field, just like different people will move through the crowd at different speeds depending on their popularity. And the Higgs boson is just a clump in the field, like a rumor crossing the room. Of course, this analogy is just that, an analogy. But it's the best analogy anyone has come up with so far.